Hi everyone. So in this video, I just wanted to go over Mann-Whitney U-test, what exactly it does. So remember, it is equivalent to the independent sample t-test. Unlike the independent sample t-test, Mann-Whitney U-test allows you to draw different conclusions about your data, depending on the assumptions you make about your data distribution. So these conclusions can range from simply stating whether the two populations differ through to determining if there are differences in medians between groups. So these different conclusions hinge on the shape of distribution of your data, which I'm going to explain a little bit in detail. Uh, so remember, if we take one step back, the Mann-Whitney U-test is used to compare difference between two independent groups when the dependent variable is either ordinal or continuous, but it is not normally distributed, which means you cannot apply the classical normal theory test like a independent t-test. For example, you could use the Mann-Whitney U-test to understand whether attitudes towards pay discrimination, where attitudes are measured on an ordinal scale, differ based on gender. So your dependent variable would be attitude towards pay discrimination, and your independent variable would be gender, which has two groups, male and female. Alternatively, you could use Mann-Whitney U-test to understand whether salaries measured on a continuous scale differed based on educational level. So in that situation, your dependent variable would be salary and your independent variable would be educational levels, which has two groups, let's say high school and university. So the Mann-Whitney U-test is often considered the non-parametric alternative to the independent t-test. But the kind of conclusion or the hypothesis that you will formulate, it hinges, or it basically depends on the shape of the distribution of your data. So it is very important that you plot your data using an app, online app, or whatever, to see what it looks like. They should have similar shape, or exact same shape is fine too. So I just found an example, a graphical example that I wanted to show you. So there are four assumptions when you are going to when that must be satisfied if you want to apply Mann-Whitney test. Assumption number one is your dependent variable should be measured at the ordinal or continuous level. Examples of ordinal variables include Likert items, like you give rank someone on a 7-point scale, strongly agree to strongly disagree, or among other ways of ranking categories, 5-point scales explaining how much customers like a product, ranging from not very much to yes, a lot. Examples of continuous variables, we all are familiar with them, include revision time measured in hours, intelligence measured using IQ score, exam performance measured using a score from 0 to 100, so weights of individuals, and so on and so forth. So you can I actually, there was a lab that you had to do where you could learn different levels of measurement. So keep in mind, the first thing is the data should be either ordinal or continuous. That is your dependent variable. Your independent variable should consist of two categories, two independent groups, right? If you have more than two, then you would use Kruskal-Wallis test. Examples of independent variables are gender, you're trying to compare something, some sort of opinion between males and females, employment statuses, smoking status, and so on and so forth. So that's the second assumption. You have two categorical independent variable. Assumption number three, you should have independence of observations, which means there is no relationship between observations in each group or between the groups themselves. For example, there must be different participants in each group, with no participant being in more than one group. So each group has different participants, and there is no common participant between the groups. If your study fails these assumptions, you will need to use other statistical tests but you cannot, instead of Mann-Whitney, you test. An example would be Wilcoxon's sign rank test. You could use that then. If you are unsure whether your study meets this assumption, you should, I mean, there are, you should go back and see what are the you can use some online statistical test selectors, but I would ideally go back and review and see what works and what doesn't work for my data. But the key assumption that I wanted to discuss is assumption number 4. A Mann-Whitney U-test can be used when your two variables are not normally distributed. But however, in order to know how to interpret the results from Mann-Whitney U-test, you have to determine whether whether your two distributions, that is distribution of scores for both groups of independent variables, for example males and females for the independent variable gender, have the same shape. So understand what this means, take a look at these two diagrams below. So this one here is identical distribution. So we have constructed a histogram of male engagement scores and female engagement scores, and you can't see them because they are overlapping. They have the same shape because the two distributions are identical. So they are not on top of each other in the diagram, and when the blue colored male distribution is underneath the red colored female distribution. However, in this diagram that you see here on the right side, even though both distributions have same shape, they have different location. The distribution of one group, that is males, has higher or lower value compared to second distribution, right? So this is males and this is female in our example. In our example, females have higher values than males overall, and this is a specific, this is an indication of shape which is kind of skewed towards right. If the two distributions have different shapes, you can only use Mann-Whitney U-test to compare mean ranks. So when you analyze your own data, it is extremely unlikely that your two distributions will be identical. This situation is very unlikely, but they may have the same shape. If they do have the same shape, you would use Mann-Whitney U-test to compare the medians of the dependent variables for the two groups of independent variables. If your two distributions have different shapes, you can only use Mann-Whitney U-test to compare mean ranks. So you see, you're comparing the medians in first case, but if the shape is not same, then what you're comparing is just the mean ranks. So that was the whole point of making this video. So if they have similar shape, you can compare medians. If they don't have similar shape, they are comparing the mean ranks only.